Hey guys, we're back today with my good friend Matt the Laxative Mashad, and today we're going to be doing a few more physics problems.
It's going to be a
Matt,
real hoot and a holler, I tell you what.
yeah, exactly. Go ahead and read this question out loud, Matt.
You got it. So, a baseball pitcher throws a baseball with a speed of 43 meters per second. Estimate the average acceleration of the ball during the throwing motion. In throwing the baseball, the pitcher accelerates it through a displacement of about 3.5 meters from behind the body to the point where it is released.
Awesome. So yeah, Matt, what are we actually solving for in this question? What is the unknown?
The unknown is the acceleration between the ball being pitched from the beginning of the throw to when the ball is released. So it's not the acceleration of the entire pitch, it's just during this throwing motion.
Perfect. So we're finding the acceleration. Do you know the initial velocity here?
The initial velocity is 0.
Do you know the final velocity?
The final velocity is 43 meters per second.
Nice. And what other information do they give us?
We also know that the displacement of distance of the pitch is 3.5 meters.
Awesome. Okay. Do you remember the kinematic equations?
Yes. V final equals V initial plus acceleration times time.
Nice. How about the second one?
Let's see.
Oh,
Delta x
mhm.
equals V final plus V initial divided by 2 times time.
Oh, nice. Yeah, so that's a different one. V final plus V initial over 2 times time. V final plus V initial over 2 is the average velocity. However, we're not actually going to use this one. I just don't consider it in the three primary kinematic equations. We'll make that a fourth down here. This one is going to be V initial times time plus 1/2 AT squared. However, we can put that one off to the side. It's not a bad one. I just don't consider it in the three primary kinematic equations. Delta x equals V final plus V initial over 2 times time. Do you remember the third kinematic equation?
No.
So this is going to be V final squared equals V initial squared plus 2a delta x. Now, which of these three equations should we be using to solve for the acceleration, given the information that we have?
I think we should use number 3.
Yeah, number 3 makes sense to me. Can you help me fill it in?
43 meters per second squared equals 0 plus 2 times
A is our
is
unknown, right?
A is our unknown times 3.5.
Nice. All right, now we just have to do algebra to solve for the acceleration, right?
Right.
Let's begin rearranging this. What's the first thing I can do here, Matt?
First thing we can do, can we divide each side by 2?
Yeah, we can divide each side by 2 and 3.5. So we get 43 squared over 2 times 3.5. And actually, we're ready to solve this. Go ahead, pull out your calculator, and we're going to do 43 squared divided by, open parentheses, 2 times 3.5, close parentheses. And let me know what you get for your answer.
My answer was 264.1
That's what I got. What are the units?
meters per second.
Meters per second squared, because it's an acceleration.
Okay.
Nice. Great stuff. How you feeling about this problem?
I feel good.
Yeah, you understand it?
Yes, I see that we had to use the equation where we only had one variable missing. We didn't
Yeah.
have time, and the other equations had time, and it would have been a lot harder to solve this if we needed time to finish the problem.
Nice, perfect. So this problem's not too complicated. We could do it with a single equation. We had all of the variables except the unknown, which is ideal. Perfect. Great stuff.